What's going on, everybody? Gareth here, FCP Euro. Welcome back to another tech tip video. Today we're going to be talking about the suspension that you'll find on F80 M3s, F82, F83 M4s, and F87 M2s. All those vehicles are essentially the same chassis, slightly different wheelbases, but all of the parts on them are pretty much shared in terms of your control arms and things like that. So let's talk about some of the parts we have here on the table, because these things that you're seeing right here, which are the control arms, these are going to be the most commonly replaced part on most vehicles. Listen, when it comes to this platform, there's tons of different options in terms of coilovers and shocks and, you know, different control arms. I mean, it's a really good tuning platform. A lot of people use it for different things between racing, show cars, etc., everywhere in between. So there is almost no limit to what you could potentially do with one of these vehicles because the aftermarket support is so strong. But we have a couple options here that I want to talk about briefly. So these vehicles utilize a Macpherson double link front suspension. So we have two tension struts. That's these bigger curved control arms. These mount in the forward position on the subframe. Ball joint points downward into the knuckle. And this is essentially responsible for maintaining the caster angle of the front suspension. The inner bushing here is actually shared with the previous generation M3 from 2008 to 2013. So this is a part that you may have seen before if you've owned one of those vehicles. However, the control arm itself is totally different because the track width on the vehicle is totally different. Moving on to the wishbone, this is located in the rearward position. Ball joint points up, and this is basically the camber arm or track width arm. So this goes straight out, and this essentially sets the track width of the suspension. So the further out this would go, the more camber you would get, and the more negative camber you would get. But this is a non-adjustable arm. It has a cross-axial joint at the inboard portion, so this can basically move any which direction. It's not a rubber bushing, so it has free range of movement without any kind of binding. And to that said, there are aftermarket versions of these stock control arms that have a monoball that is already pressed in, very similar to that, or you could press one in yourself. Some of them have OE sealed cross-axle joints like you see right there. Some of them use your more race-oriented Teflon lined bearings, which are going to be a little bit harsher, particularly on the road, but those are going to deflect a lot less, so that's really up to you and how you want to use the car. Moving to the rear suspension, it's a 5-link semi-trailing arm design vehicle, so we have 4 out of 5 of those arms right here. 2 sets of these arms are actually the same in 2 different positions, so you'll see these right here. These are the same, but they get inverted. One of these is actually a toe link, and the other one is basically used as a trailing arm. So same width, same everything on that front. What's interesting on these is on the inboard position, because these are flip-flopped, some of these have a rubber bushing in the inboard position, and then it has the cross-axle joint on the inboard position, and then vice versa, depending on which way it's being installed. Rubber bushings have to be torqued at right height, while these cross-axle joints can be torqued at full droop or full compression. It doesn't matter because the entire thing rotates and moves around. And then we have these arms right here, which have an incorporated ball joint and rubber bushings. So your failure on these is going to be, you know, the rubber bushing is going to tear after a while, or the ball joints develop play. And to that point, these cross-axial joints, while they are great for lack of deflection and allow full articulation of the suspension, these can wear out over time and start to develop play and knocking noises. So that is something to keep an eye on as well. Some other options we have, for example, SPL parts. These would be fully adjustable control arms that are using a Teflon lined bearing. They're fully rebuildable, but for something like this, you would be deleting the eccentric adjustment for your toe in order to get a little bit more fine-tuning adjustment and to also lock that alignment in. So for any vehicle that's being used as a track car, eccentric bolts and washers can move with the suspension being under compression and the car being driven very hard. So these types of adjustable control arms are really great for track use vehicles. If you have a vehicle that's really low, or you know, you're looking to get certain alignment specs that are outside of the range of your stock eccentric hardware, you could look at these SPL parts for a street car However, do be warned that these do introduce a little bit of additional NVH into the car because of the Teflon line bearing, and these Teflon line bearings do wear out over time. That's a normal thing, but the positive is that you can just replace the Teflon line rod end and put new ones in and pretty much essentially continue to rebuild these parts for the foreseeable future. So this will be a good option for track use or for those of you who are looking to do something very specific with your car. The key point in all of this, there's almost no limit to what you can do suspension-wise with these vehicles because the aftermarket is so strong. And we do carry a lot of those options here at FCP Euro. But with that said, let's lift the car up in the air. We're going to show you some of the things to look for, wear items, other things to be aware of the suspension on these vehicles, and some of the cool things that BMW did to really beef up this chassis, starting from the F8X, F2X chassis with your standard 2, 3, and 4 series. So we're going to get up the air and we'll show you underneath. So before we get to like control arms and all this kind of stuff, let's just talk about the front subframe. The front subframe is 100% unique to the F80, F82, F83, F87. It's an aluminum subframe, so it's very lightweight, and it has 8 mounting points to the chassis as opposed to 6 on like your F30s and F22s and F23s. So it's a very lightweight subframe, and then there's a aluminum reinforcement plate that bolts to it. So you can see these riv nut inserts right here. Mounts in 8 locations, so 1, 2, 3, 4, 5, 6, 7, 8. So 8 bolts hold that in. And 100% do not drive the car unless that reinforcement plate is reinstalled because it is structural and it makes sure that this aluminum subframe can't shift or bend or anything like that. So you need to have that bolted on, and the bolts that are used for that reinforcement plate are one-time use. I'm not gonna lie, I've reused them, but they are torque to yield. It's 56 Newton meters plus 90 degrees if I remember correctly, and they're M10 bolts, 16 millimeter drive. So it's up to you whether you want to have a bunch of those bolts laying around to do it, but you can reuse them a couple times if you really needed to. You'll be fine. But again, make sure you have that reinforcement plate on. But lightweight subframe, like hilariously light. You can lift the whole thing with control arms attached very easily. And speaking of lightweight components, let's talk about the control arms. So these are specific to the M chassis cars. So the wishbone and the tension strut, the general design principle is the same, and this design has been used for a long time. You have a tension strut, or this could also be referred to as a caster arm. This basically sets your caster angle, and then this control arm sets your track width or camber. There's no adjustments here, so this is not adjustable, this is not adjustable. The only thing that's adjustable is your toe, which is going to be done via the tie rod. This is an M specific part, this is an M specific part, this is an M specific part. The thing that's really unique though is the thrust arm bushing, which is right up in there. That is the same thrust arm bushing that was used on the E9X M3, so that's a carryover part. And this needs to be torqued at ride height. The wishbone, just like the outgoing E9X M3, this has a cross-axial ball joint in it, so you don't have to torque this at ride height. It can pivot any which way direction. And a really, really popular upgrade on these cars, by the way, is to press that bushing out and put in a monoball option. So we have choices from Synchro Design Works already pre-pressed into the control arm, and there's also an option from Dynon where you can upgrade that to the same style joint that this has. The hardware for the control arms is one-time use only. It's all torque to yield. I believe it's 100 Newton meters plus 90 degrees, so BMW's recommendation is to replace those screws and nuts. And then on your ball joint end, you have these 21 millimeter nuts. It's all the same, and those are torqued to 175 Newton meters. And those are one-time use only because they are a lock nut. So the other thing that is really important is we do need to replace these parts. The ball joints are not tapered, so you don't need to use a ball joint separator to get these out. They will just come out on their own. The only issue you're gonna run into is because there's no taper, you do need to counterhold the ball joint stud with a T45 Torx, and you need to use a 21 millimeter wrench to get these off. So break torque free on the nut first. Once that's free, put a counterhold in there, take the nut off, make sure that you're pressing this down. There is like these imprinted sort of locks on the ball joint conical seats. They're really not conical, they're more like a ball shape that sits in and locates the ball joint. You don't want those to just spin around and eat away at the knuckle. You want those to remain in place because it's almost like a lock. So push it down, make sure the ball joint stud is not spinning, and then these will just come out no problem. Your wishbone joint comes out no problem. The only thing that is kind of annoying on this car is if you want to do the front thrust arms, you have to loosen your auxiliary coolers because the bolt can't come out unless this is out of the way. But that's only held in by a couple of T30s, so you can loosen those up, kind of put them off to the side, pull the bolt out, and then you're golden. But it's just kind of one extra step. The thing that is of note is the whole strut tower reinforcement plate, or the strut tower itself. The way that it links into the strut tower is it actually bolts to the strut mounts. So back in the day, you used to be able to take a guide pin out or a lock pin and basically like move the strut mounts a little bit to, you know, either add some camber or take away some camber. If you have this issue with the chassis where, like, let's say it's tweaked a little bit and you're way off on your camber adjustments, the only way that you can fix that camber problem on these cars is by replacing the knuckle. They have a positive camber correction knuckle, which adds or actually takes away about ½ a degree. And then they have a negative camber correction knuckle, which adds -½ a degree. You could also fix that with a camber plate, but technically, per the BMW situation, the standard knuckle is used on all the cars, and if you have to do some kind of crazy camber correction, the only way that you can do that is by replacing the actual knuckle itself, which is kind of wild, but it's only because the strut tower brace bolts to the strut mounts. You can't move that. It basically locks it in. So that is the only downside to that setup. So on your front left suspension, you're going to have your headlight level sensor, which is directly connected to the front left wishbone. And you have like the little level arm right here and the sensor. That's only going to be on the front left. You have your sway bar link, which connects to the strut, sway bar here, sway bar bushings. The front sway bar is super easy to replace because it's below the subframe. So, you know, let's just say the bushings were worn out or you wanted to upgrade the sway bar. That is not a huge lift. Looking at our strut, this car has electronic damping control or M variable adaptive suspension. So we have vertical speed travel sensors on the strut, and there's connectors that go to it. If you were replacing struts on these cars, it passes through the knuckle. Nothing pains me more than seeing somebody hammer in a chisel or a screwdriver to spread that pinch open. There are special spreader tools that you can kind of put in there, gently open it up, and then slide the knuckle off the strut. Don't hammer it off. It's a cast aluminum knuckle, so it is strong, but it's not bulletproof like a steel knuckle. And no matter what, do not use a hammer on any of the cast aluminum parts because you will absolutely damage them and if not break them. And that's also a safety concern. So there's a very easy way to separate the knuckle from the strut. The tools are not that expensive. Replacing a knuckle, replacing any of these parts unnecessarily is an expense that outweighs the cost of the tool. So we're moving towards the rear suspension, and before we get there, let's talk about some of like the M-specific chassis reinforcements that BMW did. This is not one of them. This AWE cross brace or trans tunnel brace is because of the AWE exhaust that's on this car. The factory piece looks like this, and this could be installed on like your F30s. It's basically the same location, same concept, but instead of it being some stamped steel part, it's aluminum because aluminum's lighter and ultimately provides the same strength in this application. But then we have our brace that comes all the way back here to the subframe, and this is a F80, F82, F83, F87 specific or style part. So we have our forward portion of the rear subframe tied into this, so you don't get any kind of weird movement like that. This is all about tying in the rear suspension and making it as rigid as possible. And the subframe used on these cars is, again, like the front subframe, the rear subframe is specific to the M2s, M3s, and M4s. The one thing that makes this car unique is the fact that there's no subframe mounts. And what I mean by that is traditionally in the world of BMW, they always used rubber mounts for the rear subframe. The F10 M5, I believe, was the first BMW that got away with rubber mounts on M cars. Then the F80s, F82, F83s, and F87s followed suit. So if you look at the main mounts, these go direct to the body of the car. So these are tied in. The whole rear subframe, whole rear suspension is literally bolted to the floor of the chassis. And if you know about BMW's past on 3 Series models and the strength or the long-term strength of the floor at the rear of the car, you know that like E36s, E46s were very fragile and would tear. This should tell you how stiff and how structurally sound this chassis is, that you can have the rear subframe bolted directly to the car and not have any unintended noise, vibration, or harshness come through the chassis. So BMW did a lot of work on this platform to reduce a lot of that and to also make the chassis super, super strong. And anytime you can strengthen the chassis and the rigidity is going to make the car handle much better, respond much better, because you don't have any of this slop moving around. That said, all of the control arms in the rear are M3, M4, M2 specific. This setup is unique to this car, so it doesn't share anything in the rear end with the F22, F23, F30. All of this is bespoke to this car. So let's talk about some of this. So I said how this brace ties into multiple points on the rear chassis. So we have it up here at the trans tunnel, comes back here at our rear corner section of the car, and then it also bolts directly to the forward section of the floor up here. So we have tie-in point here, tie-in point here, tie-in point here, and then this bolt is for our trailing link. So the trailing link, think about this, as you're driving down the road, everything wants to pull back. This arm is tied directly into one of the strongest points of the car, so you're not going to have any unwanted movement here. So this is a very strong portion of the car. This means that through suspension travel, through lateral acceleration and lateral loads, you're not going to get any unwanted twisting or motion, which means that your desired toe curve of the suspension is always going to be very consistent. It's not going to move around. One thing that is really different on this car as opposed to, like, let's say the E9X M3s. I'm an E9X M3 owner, so I know a little bit about it. They moved a lot of the control arms into a dual shear configuration. So like here at the knuckle, this is dual shear. Our toe link here is dual shear. This is single shear here and single shear here. But these arms down here, they move to a dual shear configuration, which I like to see. That's going to be a lot stronger, a lot safer. That way if the joint were to ever fail, you're not going to have to worry about the part just falling off. So this is a change that they made on the F8X series of M2s, M3s, and M4s over the outgoing E9X M3s. And again, all these parts are specific for this car. So we have our trailing link here, lower trailing link, and an upper trailing link. And then this part right here that's used as a trailing link is the same part that's used for the toe link. Moving kind of here to the back, your adjustments in the rear are going to be toe and camber. So we have our lower spring arm here. This really sets the track width of the suspension. We have a cross axial joint right here at the knuckle. These can be replaced, they can be pushed out. Rubber bushing for our factory shock. Rubber bushing here at the subframe. Our camber adjustment is done via an eccentric bolt, and it's right here at the outboard side. What's nice about this setup is because it goes through a ball joint, you don't have to worry about binding or unloading the suspension. You can make this adjustment. There's not going to be any kind of resistance that you might have with a normal rubber bushing. So this makes this adjustment much easier than in a lot of other applications. So it's a really nice feature that was kind of put into this car. And then your toe link is right here. Your toe adjustment is done via this bolt here. Now this goes through rubber bushing. So a little bit of modularity used there, which is always smart. It's fewer parts in the parts bin. But the biggest change with the rear control arms on your F80s is these are all aluminum pieces, all forged aluminum. So lightweight, very strong. If you've ever worked on like an F22 2 series or an F83 series, you'll know all the stuff in the rear is basically stamped steel and is pretty cheap and flimsy. All of this stuff has been upgraded for the intended use of this vehicle, which is a driver's car. It's going to be used for track driving, back roads. Somebody who's going to buy an M car is going to want to actually drive the car. So the performance from handling and the feedback was all tied into making sure these parts were as strong and lightweight as possible. Because if you can reduce the weight and you can reduce the deflection, the car is always going to handle much better. Of course, we have a divorce setup in the rear. A lot of your 3 Series models have always been that way, so the spring sits inboard from the shock. However, you might hear about like rear suspensions, motion ratios, things like that. On a Macpherson Strut, because the spring is on the shock body, it's 1-to-1. So 1 inch of movement on the shock is 1 inch of movement on the spring. So it's a 1-to-1. On a lot of outgoing 3 Series cars, the spring sat really, really far inboard of where the shock mounted. And so you end up with a really wide split in your motion ratio. So like an E36 or an E46 would be like 1.6-to-1. So the shock would move 1.6 inches to 1 inch of movement on the spring, for example. So you have to have a ton of spring rate to overcome that, because your rear control arm is basically acting like a lever at that point. But you can see here that the shock body is very close to the spring. So this has a pretty close motion ratio for a divorced rear setup suspension. So, the spring rate tuning for your factory stuff is gonna be within a pretty close proximity. And, you're not gonna run a crazy high spring rate in the rear because you don't necessarily need to. But that said, like the upper spring seat, that kind of carries over from your E9X cars. So like that upper rear spring seat sits in a little locating hole on the body. If you're installing a aftermarket coilover, for example, the spring seats or the adjustable spring seats are always going to sit at the top. So just knock that out, put the spring seat that comes with the coilover kit up top. That way you can actually adjust the ride height easily. That's where it's supposed to go. The only thing that I'm going to be critical of BMW for on this car is the use of plastic sway bar end links in the rear sway bar. Don't really know why that was a design choice, but that's literally plastic. All of this other expense, and I don't think it would have been that big of a deal to do, a proper aluminum sway bar link. Another thing I could say in comparison to, like, let's say an E9X 3 Series, the rear sway bar link is much easier to replace. If anybody who's ever done rear sway bar links on an E9X M3 or 3 Series, you'll know what a nightmare that is. So this is actually in a place where it's serviceable. And that's a good thing too, because I don't think these plastic end links are long for this world, especially if you use the car in an aggressive manner. There's quite a bit of torque that goes through the rear end of this car. Everything is tied down really, really, really tight, except for the diff. So we have this carrier or adapter that bolts onto the back of the diff that supports it in place, but it's only supported on the back side in one place. And then up here we have a different adapter where this diff bolts to. This differential really needs a lot more support in the rear. So there's dual diff mount brackets that allow you to add an additional bushing. And it's strange, and we'll show you. There's really 2 holes on the subframe, both the same size. So it was almost like it was intended to have 2 diff mounts, and BMW just chose to do 1. Because there's no reason why you'd have the sleeve welded onto the subframe for a diff bushing if you never had the intention of putting a diff bushing in there to begin with. So there is a way to put two diff bushings into this rear subframe and really help lock down the rear diff. We offer a kit from RevShift that has a new billet adapter. You push in the new subframe bushings, really tie down the rear end. And another thing to note, BMW did have issues on early production cars with the factory rubber diff bushing just basically tearing out. From the factory, they were upgraded to a polyurethane bushing. So the rubber bushing is no longer available. It's now a poly bushing. This car is very early production, so of course it has the rubber bushing that is failure prone. So this car has the standard rubber mount, and I can already see some cracking at the lower end here. But this is the main mount for the rear diff, and it's on the left side. If you look on the right side, we have a sleeve welded to the subframe that's the exact same size as this, but there's no way to actually bolt it to the diff because this adapter bracket doesn't have a mounting point for it, which is why the dual diff mount bracket kits that are out there, the one that we offer from RevShift as an example, basically creates a mounting point. You push a bushing in there, and now you have the diff really locked down. Because when you're loading the drivetrain, this wants to go this way. It's going to shift that way. So this is just offering another way to tie down the diff more. A diff that moves around is also going to create axle hop. It's going to put a lot of load into these axles. You could damage these axles. They are very expensive. So I would say for anybody who has one of these cars, the dual diff mount conversion is the thing that you really want to do. And if you have, at the very minimum, if you have the rubber bushing still in them, get rid of it and upgrade it to the factory poly bushing that BMW offers. At minimum, you should do that. At most, you should convert to a dual diff mount in the rear. So quick note on the rear shocks. Bolt directly here to our camber arm or spring arm. Goes up to the inside of our body or wheel well here. This is really the first generation of BMWs where you don't have to disassemble the entire interior of the car to get to the rear shock tower mounts. There's 3 torque screws that hold the shock mount to the body of the car. So replacing shocks on this is super easy. It's literally 1 bolt here, 3 screws at the top, pull the shock out, easy peasy, super easy. You don't have to worry about disassembling, like I said, half the rear interior of the car. But where BMW gives you, they take away. If you were to ever have to replace a rear sway bar bushing, or let's say you were doing a sway bar upgrade, if you follow our sway bar here from the plastic sway bar link that I complained about earlier, it comes up here and it goes up over the top of the subframe. There's no way to fish this out. So if you were looking to do a rear sway bar upgrade, at the very minimum, you were lowering the rear subframe of the car. So you have to unbolt the axle, unbolt your diff, which has a whole other conundrum tied to it. We have a video explaining the center nut on these and how to release the drive shaft from the pinion. That's a whole thing on its own. So yeah, you know, if you're planning on doing a rear sway bar in this car, you have a little bit more work planned out for you than you might have considered. So there are some complications tied with that. That is really the only negative I could say about the rear suspension on these cars is the sway bar going up over the top. But clearly with a 5-link rear, there isn't any other place for it to go. So that just is what it is, unfortunately. So one thing to note on all the vehicles that have the M adaptive suspension, on the shock absorbers, particularly here on the rear, you have this vertical speed travel sensor that's part of the adaptive suspension. You have this wiring lead that comes off of that and then goes into the e-box here on the side. One thing to note on a lot of these vehicles with higher miles or older, if you install brand new shocks and you transfer these vertical speed travel sensors over and you go to plug these in, you might find that that plug is going in very hard and doesn't seem to seat, and then you turn the car on after doing the work and you have an adaptive suspension fault. It's because the connector did not seat back into that sensor correctly. It seems to be a really common problem. There's 2 possible things. Number 1, if the shock absorber is leaking a ton of oil externally and it's dripped all the way down and it's literally on that sensor, buy a new wiring lead, because chances are the oil has gone in and has now bloated the weather pack seal in there. So there's like a little rubber grommet that's in there. Chances are that oil has now caused that to swell. It'll never seat properly again. Alternatively, if you don't have that problem, you could put a little dielectric grease on that little weather pack grommet and you push it in, you should feel it click into place. If there's resistance, it's not seated properly, and that is an issue that we've seen plenty of times on these adaptive suspensions. So just be aware of it. You can buy a new wiring lead if yours is damaged or you find that problem. Alternatively, a little dielectric grease should slip right in. But again, if that shock was leaking a ton of oil, just replace the wiring lead, because chances are that has leaked into the harness anyway. So anyway, that about covers everything you need to know about the suspension on an F80 M3, F82, F83 M4, or F87 M2. Hope you learned a lot. If you have any questions or comments, leave in the comment box below. We'll get back to you. If you like this video, hit the like button. And we have a ton of DIY content specifically coming out on this car, so you'll want to hit subscribe in order to stay tuned for that. And as always, we'll see you for the next one. Thanks for watching.